Questions 11 through 20 on the 2004 Grade 10 AMC 10A. A company sells peanut butter in cylindrical jars. Marketing research suggests that using wider jars will increase sales. If the diameter of the jars is increased by 25% without altering the volume, what percentage must the height be decreased? So we've got a cylindrical jar, something that looks like this, correct? And we are going to make it wider. So if we make it wider, then the height's going to go down because we want the volume to be the same. So something like that. Now, what is the volume of a cylinder? It's pi r squared, which is the area of the circle at the top, multiplied by its height. And we'll call this V1, we'll call this V2. So V1 is pi r squared times H1. And V2 is pi, same radius, or not? Yes or no? No, because the diameter increased by 25%. So if the diameter increased by 25%, it became 5 over 4D, right? D1 did, when you go from D1, I guess, to D2. So I guess if this was D1, this would be D2, right? And then radius is basically half the diameter. So the exact same scenario happens for the radius, where R2 basically is 5 over 4 times R1. Okay? So this is R1. This would basically be 5 over 4 times R squared. And then the height is H2. We don't know that yet. That's what we're trying to figure out. Now these volumes are the same without altering the volume. So we can set them equal to each other. So that means pi r squared H1 is equal to pi 5 over 4 r all squared times H2. The pi's cancel, and eventually the r's will cancel, but let me just do the r's first. 25 over 16 r squared, like that. Okay, now I'll cancel out the r's, and we just get left with H1 is equal to 25 over 16 H2. So that basically means that H2 is 16 over 25 times H1. So that means that H2 is going to be 16 divided by 25 times H1. So we want to know how much did the height decrease by. Let's just give them some numbers. You don't have to really, but if H2, for example, is what we're trying to figure out, let's say H1 was, let's say it was 100 to begin with. Well, what's H2? Well, 16 divided by 25 times 100, which would be, let's see here, we got 100 divided by 25, which is 4. So 4 times 16 is 64. All right, so we started with a height of 100, we got down to 64. How much did it decrease by? What percentage? Well, it looks like it went down by 36, or 36%, because we're using 100. So number 11, the answer is C. Henry's Hamburger Heaven offers its hamburgers with the following condiments: ketchup, mustard, mayonnaise, tomato, lettuce, pickles, cheese, and onions. A customer can choose 1, 2, or 3 meat patties and any collection of condiments. How many different kinds of hamburgers can be ordered? Okay, so the patties are pretty straightforward. We've got 1 or 2 or 3. But the condiments is a little bit more tricky. So what I'm going to do is I'm just going to concentrate on the 1 meat patty. And then for the 2 and the 3, it'll be exactly the same. So I'll just multiply my answer here, big long answer, whatever I get. It'll be the exact same for 2 patties and 3 patties, right? So here we go. For condiments, right, that is a little bit more tricky. We can have 0 condiments, we can have 1 condiment, 2, 3, 4, 5, 6, 7, or 8. There's 8 condiments, correct? 1, 2, 3, 4, 5, 6, 7, 8, correct. So they don't tell you that you have to choose 4 condiments. No, it could be anything, any order. So how do we do this? We use something called choose. This is a grade 10 math contest, so you probably should know choose by now. I'll give you a scenario. Let's say you have 5 cookies, 1, 2, 3, 4, 5, and they're all a different flavor, chocolate chip, oatmeal, blah, 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 right? And from those 5, you want to choose 2. So 5, choose 2. How many ways? In how many ways can you choose 2 cookies from 5? 5, choose 2. Well, what is that? It's 5 factorial divided by 5 minus 2 factorial over 2 factorial. And you do the math, and whatever number is the number of choices. So for example, this will be 5 factorial over 3 factorial over 2 factorial. And that is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1, correct? So this guy cancels with that guy. You get 5 times 4, which is 20, 20 over 2, so 10. So there's 10 ways. If I said to you, from 5 cookies, choose 2, how many ways can you do that? There's 10 ways. So that's exactly what we're going to do over here, but it's going to be done quite a few times. I want 0 condiments. So from 8, choose 0. All right? And that is equal to 1. I'll let you do the math, just like how I did the math over here. I'll let you do the math. From 8 condiments, choose 1. Okay, 8, choose 1. 8, choose 1 is equal to 8. From 8 condiments, choose 2. Okay, 8, choose 2. 8, choose 2 is basically 8 factorial over 6 factorial over 2 factorial, and the number value is 28. All right, hope you're getting the hang of this. 8, choose 3. I want 3 condiments. How many different ways of that happening is there? 8 factorial over 5 factorial over 3 factorial, and this is 56. 8, choose 4 is equal to 70. 8, choose 5 is equal to 56. You'll notice that numbers start going back as that, in that direction, the same. And then 8, choose 6 is 28. 8, choose 7 is 8. And finally, from 8, choose 8. Well, there's only one way of doing that. So now you add up all of these guys here. Add them up. And if you do, you get 256. Okay? So this is 256. That's the number of different ways you can arrange all the condiments. And then that's for 1 patty. For 2 patties, it would be the exact same thing. And for 3 patties, it'll be the exact same thing. So the grand total will be 256 plus 256 plus 256, which is equal to 768. That's the different kinds of hamburgers that can be ordered. So number 12, the answer is C. At a party, each man danced with exactly 3 women, and each woman danced with exactly 2 men. 12 men attended the party. How many women attended the party? So what I'm going to do is, to make things a little bit easy for you to understand, I'm going to, instead of using 12, I'm going to use 4 men, and then I'm going to explain it, and then we can extrapolate our answer to 12. Let's say there's only 4 men at the party. Man 1, man 2, man 3, man 4, like that. And we don't know how many women, but that's fine, we can figure this out. Initially, the first man dances with exactly 3 women. So W1, W2, and W3. The second man dances with exactly 3 women. So let's say he dances with the same W1, W2, W3. Okay, now before I get to M3, let's see if the condition holds true for the women. Each woman danced with exactly 2 men. Okay, let's see. W1, she dances with M1, and W1 dances with M2. Okay, that's fine. That works. W2, she dances with M1, and W2 also dances with M2. Again, each woman danced with exactly 2 men. That condition is satisfied. W3 danced with M1, and she danced with M2. So that basically means that those 3 women are done dancing with the men. Once we get to M3, we have to choose new women. So we'd have to choose like W4, W5, W6, and very similarly for M4, W4, W5, and W6. And if you go through this, you'll find that all the conditions are met. So in the scenario with 4 men, the conditions are met with how many women? It looks like 6 women. All right? So I hope that made sense. The ratio of the men to women will be 4 men to every 6 women. Now in our question, they have 12 men, and they want you to figure out how many women, X. Well, this is a simple cross multiplication question. 4x will be equal to 6 times 12, and therefore 6 times 12 divided by 4 is our x. So 12 divided by 4, 3. 3 times 6 is 18. So there are 18 women when there are 12 men. So the answer to number 13 is D. The average value of all the pennies, nickels, dimes, and quarters in Paula's purse is 20 cents. If she had one more quarter, the average value would be 21 cents. How many dimes does she have in her purse? So P plus 5N, because a nickel is 5 cents, plus 10D, because a dime is 10 cents, plus 25Q, because a quarter is 25 cents, divided by the number, which is P plus N plus D plus Q, is equal to 20 cents. That's our first equation. There's a 1 in front of the P because a P is a penny, which is only 1 cent. Now our second equation is a little bit similar. It's 1P plus 5N plus 10D, but 1 more quarter. So instead of 25 times Q, it's 25 times Q plus 1. And the denominator is pretty much the same, except you have to add 1 additional coin. So Q plus 1 like that. And they tell you this average is 21 cents. All right, so we have to manipulate these to get a value for D, how many dimes. All right, no problem. So the first guy here, basically it looks like P plus 5N plus 10D plus 25Q is equal to 20 times P plus N plus D plus Q. All right, so I'll substitute that into here, right here. So that means that this P plus 5N plus 10D plus 25 is going to be this right here. 20 times P plus N plus D plus Q, like that. But remember, don't forget there was a 25. When you multiply this out, you get a 25 at the end. So it's 25 like that. And then this guy and this guy, we can put them all in the same line, cross multiply. So it'll be 21 times P plus N plus D plus Q. And don't forget to put this final 21 in there, like that. So now let's put the 25 and 21 on one side, so it would become 25 minus 21, which is 4. And then we can put this and this on one side, and it just becomes P plus N plus D plus Q. So there you have it. Basically, our pennies, nickels, dimes, and quarters equal 4. That is a very helpful equation, and now we have to kind of use trial and error to figure out how many of each do we have. So let's say we have one of each. One of each. If we do, that would mean we have 1 penny, we have 1 nickel, 1 dime, and 1 quarter. And our average, divided by 4, this looks like 25, 35, 40, and 41 divided by 4. It's 10.25. Well, that doesn't work because our average, if you remember, for the value of all pennies, nickels, dimes, and quarters is 20 cents. Okay, no problem. Let's try this again. How do we get 20 cents? How about if we have 1 nickel and 3 quarters? I think that should do it. That would mean you'd have 0 pennies and then 1 nickel, so 1 times 5, 0 dimes plus 3 quarters, 3 times 25, and you're dividing by 4 coins. So it looks like 5 plus 75, which is 80. 80 divided by 4 is indeed 20. All right, perfect. And then the other scenario was that if we added 1 more quarter, the average becomes 21. Okay, let's do that. 1 more quarter. So we have initially 1 nickel and 3 quarters. Let's say 1 more quarter. So 4 quarters, and let's see what we get. Now the average becomes 0 for pennies, 1 times 5 for nickels, 0 for dimes, and 4 times 25 for quarters. And dividing this time by 5 coins, this looks like 5 plus 100, so 105 over 5, and that is indeed 21. There you go. So we have 1 nickel and 3 quarters, and then if you add 1 more quarter, we get 1 nickel and 4 quarters. So what is the question asking? How many dimes does she have in her purse? Well, she has 0. She doesn't have any dimes. So number 14, the answer is A. Given that minus 4 is less than x is less than minus 2, and 2 is less than y is less than 4, what is the largest possible value of x plus y over x? So x plus y over x is at the heart of this question, and we got to mix and match here. So as always, just use extreme case scenarios. For x, I'll use minus 4, and then for y, I'll use 2. Let's see what we get. These are the extreme case scenarios, right? Those are the lowest values for each. So x plus y over x becomes x is minus 4, y is 2 over minus 4. So this is basically minus 2 over minus 4, which is positive a half. For x is minus 4 and y is 2. So let's go x, keep it at minus 4, but let's use the other extreme for y as 4. So again, plug these into that one, and we get minus 4 plus 4 over minus 4, and that is 0. Okay, so let's go to the other extreme for x, minus 2, and let's start using our extremes for y. Y is equal to 2, and then I'll use x equals minus 2, and then y equals 4. The other extreme for y, like that. All right, let's do this. So we got minus 2 plus 2 over minus 2, and this is again 0. And then finally, minus 2 plus 4 over minus 2, so that's 2 divided by negative 2, which is negative 1. So I've used all my extreme case scenarios. Everything else will be an answer in between one of these 4 answers. So what is the largest of these? The largest is a half. So 15 will be D. The 5 by 5 grid shown right here, this one right here, contains a collection of squares from sizes 1 times 1 to 5 times 5. How many of these squares contain the black center square? Okay, good question. So I'm going to break this up into sizes. So first let's figure out the squares that are 5 by 5, then 4 by 4, then 3 by 3, then 2 by 2, and then finally the smallest ones. And then how many of them, that's what I'm going to put in that column, and then how many contain that black center square. So let's start with 5 by 5. 5 by 5 is pretty easy. There's only one possible square that has the full 5 by 5. So that means there's only one. And that one, does it contain the center black square? Well, of course it does. So of the one that I drew, how many contain the black center square? Well, one of them. So now let's turn our attention to 4 by 4. 4 by 4 are of that nature, right? So how many are there, first of all? There's one here. There's one here. That's 2. And then I've got one here. And I've got one here. Like that. So that's 4 of them. Now, of those 4, how many contained the center black square? Well, if you remember, all of them did. Now let's turn our attention to 3 by 3. So 3 by 3 is like this. 1, 2, 3. Correct? And then we got 4, 5, and 6, and 7, 8, and finally 9. 9 of them. Now of those 9, how many contained the black center square? All of them did. All right. Now let's pay close attention to the 2 by 2. I want you to not only see them, but I want you to start thinking about this guy here. How many contain the black center square? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and finally 16. All right, got a little outside the borders, but that's okay. 16 of them. Now, did you count how many contained the black center square? Only 4 of them did. And then finally, 1 by 1, I'm not going to go through all of those because that's pretty obvious, right? They're just these little guys in here. And you can easily tell that there's 5 times 5, which is 25 of those. And because there's 25 of those, you can pretty much figure out how many of those have the black center square. Well, it's just the one that's the black center square. That's the only one that will contain it. So there you go. Now we just have to add up all these. So that looks like 5, 5, and 9. 19. 19 is the answer to this question. So that would be 16 is D. Brenda and Sally run in opposite directions on a circular track starting at diametrically opposite points. They first meet after Brenda has run 100 meters. They next meet after Sally has run 150 meters past their first meeting point. Each girl runs at a constant speed. What is the length of the track in meters? So here is the circular track, and they're starting at diametrically opposite. So if Brenda starts here, Sally has to start completely opposite. And then we don't know this track in terms of its size. That's what we are trying to figure out. So Brenda first runs 100 meters, right? So let's just say she gets to about that point. So this is 100 meters of running. And Brenda is now here. And that's when she first meets Sally, because Brenda's running in that direction and Sally is running in the opposite direction. So now Sally is also there. Okay, Brenda and Sally are now at the same point. Now Sally ran from here to here, and we don't know the distance, so I'll just call that distance X. All right, so they continue running. Brenda now runs this way, and Sally now continues to run, but she's going this way. They say Sally now runs 150 meters past their first meeting point. So Sally gets to about here. If from here to here is 100, and she's running 150, from here to here must be 50. So I'll label that 50. And now Sally is here, and Brenda meets up with her. So Brenda is now here also. Now we denoted from here to here to be X, so we're going to call from here to here Y, since I don't know the value. All right, so I've got some variables and some distances. Now there's a variable that I definitely need to use, and that's speed. And speed is equal to distance over time. And this equation we will use a few times in our question solution. Now, the first time that Brenda is running from here to here, that's 100, right? So we're going to use that as our distance. And speed, well, we don't know her speed, so I'll just call it speed of Brenda. But I'm going to flip this equation so that I have time is equal to distance over speed. So her time, T1 I'll call it, is 100 divided by the speed of Brenda, like that. And then now let's look at Sally. Initially she was here, and she runs from here to here, like that. Her time, T2, is therefore her distance, which is x, and divided by her speed, so speed of Sally. Now remember, T1 and T2 are equal because Brenda starts here, she goes here, and in the same amount of time, Sally starts here and ends up here. So those times are equal. And because those times are equal, we can set these equal to each other. 100 over SB is equal to X over SS. So now let's look at the next scenario. Sally was originally here, then she went here, and then she travels to here. So we're going to concentrate on Sally's travel from there to there. When she does that, she basically goes 150 meters. They tell you that. And the speed is the same because they're both running at constant speeds. So the speed of Sally, and then we'll call this T3. And during that exact same time, we'll call it T4, Brenda, who is here, is going to go all the way from there to end up here. So therefore, her distance is x plus y, and her speed is the speed of Brenda. And then because they meet up, T3 is equal to T4, and therefore 150 over the speed of Sally is x plus y over the speed of Brenda. All right? Now I've got a lot of variables here. I'd like to get rid of some of these variables. Can I? Well, I can, because remember when they first started B and S, they would diametrically opposite each other like that. So that basically means that the distance from here to here is the same as the distance from here to here. They're opposite each other. So this basically cuts the track in half. So that basically means that 100, this guy, plus x is the same as 50 plus y. And therefore, instead of having y's, we can just put it in terms of x. Y would basically be 50 plus x. So this basically becomes x plus y. Y is 50 plus x. So it becomes 2x plus 50 over SB. All right? So let's proceed with this. So from the first equation we got, we can use that to basically cross multiply. 100 over SB is equal to x over SS. So we can cross multiply. We get, let's see, SS over SB is basically x over 100. And then we can do very similar with this guy here. Using this and this, we'll get 150 over the speed of Sally is equal to 2x plus 50 over the speed of Brenda. And therefore, if we cross multiply, we'll get 150 over 2x plus 50 is equal to SS over SB. And there we go. We got two ways of equating the speeds, and we can just set them equal to each other. So x over 100 is 150 over 2x plus 50. Cross multiply these, you get 100 times 150 is equal to 2x squared plus 50x. And then maybe we can factor, or maybe we need a quadratic, I'm not sure. Let's see. Put everything on one side first. Minus 100 times 150, like that, is 0. If I divide through by 2, we'll simplify things. So x squared plus 25x minus 50 times 150. And can I factor this? Let's see. X 50 times 150, 7,500, right? So I think 175 should do it. Yeah, and then plus negative like that. So there you go. So either x is minus 100 or it's positive 75. What is x? X is a distance, right? X represents this distance. So obviously it's not negative. So x has to be 75. All right. Now what is it that they want us to figure out in this question? They want the length of the track. Oh, okay. Well, length of the track, let's see. Let's add all this up. It was, let's see. We can do it here. Length of the track was 100 plus x right here plus y, but y was 50 plus x, and then plus 50. And then y, or sorry, x we got as 75. Okay, so that means we've got 100, 50, 50, that's 200. And then x is 75, so 75 plus 75 is 150. So therefore, it's 350. That's the length of the track. So 350 for number 17, so that would mean 17 is C. A sequence of 3 real numbers forms an arithmetic progression with a first term of 9. If 2 is added to the second term and 20 is added to the third term, the resulting numbers, 3 of them, form a geometric progression. What is the smallest possible value for the third term of the geometric progression? So initially we've got an arithmetic progression, which is, as I hope we know, a plus d, a plus 2d, a plus 3d, and so on. And they tell you that the first term is a 9. Okay? And then the second term they don't tell you, but they say that if you do add a 2 to the second term, and if you do add a 20 to the third term, these now become a geometric progression. And a geometric progression is of the form AR squared, AR to the power of 3, and so on. Okay, so that's the first part of the question, and let's proceed with that. So we know that if you have 2 terms in a geometric progression, A, R, and A, and you divide them, the result will just be R, right? Because the A's cancel. And you do the same with the third and the second term, AR squared divided by AR. That would also just leave R. So let's do that, but using these terms, since they are indeed a geometric progression. So that means that A plus D plus 2 over 9 is equal to some R. Okay, we don't know what R is. And then similarly, that over that will also be R. So A plus 2D plus 20 over A plus D plus 2 is also equal to R. Okay, so far so good, nothing confusing, I hope. Now we let these equal to each other since they are both R. So A plus D plus 2 over 9 is equal to A plus 2D plus 20 over A plus D plus 2. Now I've got two variables, I've got A and D, and I unfortunately have to figure out what these are, right? But the good news is they tell you. The first term was a 9. A is equal to 9. So I will substitute that in. So I've got 9 plus D plus 2 over 9. And I've got 9 plus 2D plus 20 is equal to 9 plus D plus 2. So this becomes 11 plus D over 9 is equal to 29 plus 2D is equal to 11 plus D. Correct? Cross multiply and you get 11 plus D squared is equal to 9 times 29 plus 2D, like that. So 29 times 9 is 261, and then 9 times 2D is 18D. This becomes 121 plus 22D plus D squared. Put everything on one side, D squared plus 4D. 121 minus 261 is minus 140. Let's see if this factors. I think I can. D, 14, and 10. Positive, negative, like that. So D, therefore, is either negative 14 or positive 10. All right, great. Now let's go back and remind ourselves, what is it that they want? What is the smallest possible value for the third term of the geometric progression? Okay, what is the third term of the geometric progression? It's this guy right here. So A plus 2D plus 20. A plus 2D plus 20 is what we have to figure out. The smallest value, okay? First, let's try for D equals negative 14, and then we'll plug in D equals 10. And then we'll choose the smallest. So remember, A was 9. D, in our case here, is negative 14 plus 20. So this looks like 9 minus 28 plus 20. So that's 29 minus 28, which is 1. Okay? Let's try D equals 10 now. So it'll be 9 plus 2 times 10 plus 20, which is 9 plus 20 plus 20, and this is 49. So the smallest of these obviously is 1. And therefore the answer is 1, and number 18 is A. A white cylindrical silo has a diameter of 30 feet and a height of 80 feet. A red stripe with the horizontal width of 3 feet is painted on the silo as shown, making 2 complete revolutions around it. What is the area of the stripe in square feet? Okay, so they've got this red stripe that they've painted all the way across like that. Okay, and they want you to figure out the area. Now, how on earth are we going to do that? Is there any formula or anything like that that can help us? Clueless, right? I have no clue how to do this question. All right, I'm going to write 3 words, and I hope those 3 words will help you. Open it up. So, well, how does that help me? Basically, open it up. And I don't know if they did this on purpose to help you. Perhaps, but they drew a dashed line there. I noticed that actually. Maybe they put that in there to help you, that hey, cut it and open it up. They're kind of giving you the subtle clue. And if they did, hey, that's great. So if you do open it up, what does it look like? Well, if you open it up and you flatten it out, it'll basically look like this. like that. I hope you agree with me. And when you do that, it makes life a lot easier. And I really do believe that that dashed line was given as a subtle clue. If it wasn't, hey. But it definitely does help me. And I'll tell you why it helps me, even if it wasn't a clue to open it up. Because look at this stripe. Where does it touch? Right there. You see that there? It touches right at the corner of that dashed line and the top. So I'm going to treat that as my corner right here. And therefore that first red line basically starts right here. Okay? And then where does it end? It doesn't end at the other corner. It ends here. A little bit like that. You notice how it doesn't end at the very other corner? It ends here. Now, in a very similar way, the other part of that red stripe starts a little bit to the right, but that one ends at the very corner. So I'll draw that on my diagram here. So it starts a little bit to the right, but that ends at the very corner, so like this. So that's about as good as I can draw it. Now, they want you to figure out the area of that. So if I shade this in like this, what is the area? Now, how would I figure out the area of that? I'm still not sure. Well, at this point, it's pretty straightforward, I hope, if I label it. This is obviously a rectangle, the green shape, and they've given us the dimensions, 80. And this part, you say, well, I wasn't given that, but that is the circumference of the circle, right? When you flatten it out, it basically becomes from there to there. And the circumference of a circle is basically pi times the diameter. And they tell you that the diameter is 30 feet. So the circumference is pi times 30, like that. So this is 30 pi. Okay? So how do I figure out the red stripe? Well, basically you take the total area. So the total area is the area of a rectangle. So I'll just draw that rectangle minus two triangles. That one and that one. Not very scientific here, but you all understand. Okay, let's do that. Let's figure this out. So the area of this red stripe is going to be the total area, which is the area of the entire rectangle, which will be length times width, which is 80 times 30 pi, minus the first triangle, which is 1/2 base times height. Now the base is from here to here. Now notice, be careful, it's not the full length, right? It's not the full length from there to there. It is the full length subtract something. Subtract what? This little length right there. What is that length? They tell you it's 3. They tell you in the diagram and they tell you in the question. So 1/2 base is 30 pi minus 3. And then times height, which is 80. And similarly, you're going to subtract this triangle. And that triangle is pretty much the same. 1/2 base. The base is from here to here. And be careful, it's not the full 30 pi. It's 30 pi minus that. And that is 3. So again, 30 pi minus 3. And times the height, which is 80. So this basically becomes, if you factor out an 80 from everything, which you can, it becomes 30 pi minus 1/2 30 pi minus 3 minus 1/2 30 pi minus 3, like that. Okay? So again, in brackets, we'll have 30 pi minus half, that just combines to become 1. So 30 pi minus 3, but don't forget the brackets. And then you can take it out of the brackets now. 30 pi minus 30 pi plus 3. And this basically becomes 80 times 3, which is 240. And that is the area of that red stripe. So this question, the answer is 19C. Points E and F are located on the square ABCD so that BEF is equilateral. What is the ratio of the area of DEF to that of ABE? So they want the ratio of DEF, so DEF right here, to the area of ABE. ABE right there. So let's start labeling a few things. Let's see what we can get. Since it's equilateral, I'm going to label the sides X, X, and X like that. All the sides are the same. And then I'm going to label some other sides. DF I'll call A. And because this diagram is completely symmetric, if you drew a line from B to D like that, you'll notice everything on one side is the same as the other side. So therefore, if that's A, this is also A, DE. And then EA I'll call C, and FC I'll call C like that. And then this side it's a square, so it's the same as that side. So if that's A and C, this will be A plus C, like that. And similarly, this is also A plus C. All right, so that's the labeling. And now let's figure out, through Pythagoras, the relationships between my variables. First, let's look at this triangle right there. In that triangle, triangle DEF, we've got a squared plus a squared is equal to x squared. And therefore, 2a squared is equal to x squared, like that. And then in this triangle right here, which is basically ABE, triangle ABE, like that, we've got c squared plus a plus c squared is equal to x squared. And therefore, we can expand this. C squared plus a squared plus 2ac plus c squared is equal to x squared, like that. And move this up a bit. And let's see how far we can get. A squared plus 2ac plus 2c squared is equal to x squared. And therefore, we've got 2ac plus 2c squared is equal to x squared minus a squared. And then we can use this point right here. X squared is equal to 2a squared, right? So that also means that a squared is equal to x squared over 2, like that. So that means 2a squared plus 2c squared is equal to x squared minus x squared over 2. And therefore, this just becomes x squared over 2, like that, is equal to 2ac plus 2c squared. And if you factor out the 2 there and bring it down, it'll just be ac plus c squared is equal to x squared over 4. And I think that's about as far as we can go with that. Now let's go back and look at what they want. Ratio of the area of DEF to the area of ABE. All right, so DEF would be 1/2 base times height. The base is A, the height is A. And then ABE is 1/2 base, which is A plus C, times the height, which is C, like that. Okay, let's see what we get. The halves cancel, so I got a squared over ac plus c squared. All right, this looks very familiar. a squared is right here, x squared over 2. AC plus c squared is right here, x squared over 4. So invert and multiply x squared over 2 times 4 over x squared. And that gives me the x squared cancel 4 over 2, which is just 2. So there you go. That's the ratio, 2. And therefore, number 20, the answer is D.